Hello students, in this video, we'll try to solve problems using Kirchoff's laws. Before beginning with Kirchoff's laws, let's try to understand the different steps that are required to solve the circuit using Kirchoff's laws. Now you know that Kirchoff's laws would give us the unknown values of currents and EMFs in the circuit. So in the circuit diagram that is given, the first thing that you need to do is indicate an assumed direction of currents. So simply mark the direction of currents. And also please note that if you get a negative sign in the result, it means that the actual direction of the current is opposite to your assumption. So just don't get bothered about the negative sign if at all you get it in your result, because it just means that it is the assumed direction of the current is opposite to the actual direction. That's all. All right, the next step, what you need to do is apply the junction rule. Identify the nodes in the circuit and apply the Kirchoff's current law to reduce the number of unknowns. So in this step, you will be able to express the currents in terms of as few quantities as possible. That is the advantage of using junction rule. In the third step, choose any closed loop and choose a direction, that is either clockwise or anti-clockwise, to travel around the loop while applying the Kirchoff's voltage law. Also remember to use the sign conventions appropriately while adding the potential differences. So this is the step in which most of the students go wrong while using the sign conventions. And if you get the equation, all you need to do is solve those equations to determine the unknowns. So depending on the number of unknowns, you would require the equations to solve it. That is, if you have 3 unknown values, you would need 3 equations to solve them. That's all. Now let's try to understand the sign conventions better. So this is the sign convention which I usually prefer for solving problems, because you don't have to simply by heart them. You can use physics to understand them. All right, so let's try to understand that. So for the sign conventions for EMFs, so if you come across a battery while traveling around a loop, you're traveling from the negative terminal of the battery to the positive terminal of the battery, which means that you're traveling towards a region of increasing potential, then the sign of the EMF can be taken as positive. At the same time, when you're traveling around the loop from a positive terminal to the negative terminal, you are moving to a region of decreasing potential, is it not? Then the value can be taken as negative. Now coming to the sign conventions for resistors. You know that current always travels from a region of high potential to a region of low potential. So when you are traveling around the loop, when you are going against the direction of the current, that is towards the region of increasing potential, then the potential drop across the resistor can be taken as positive, plus IR. On the other hand, if you're traveling along the direction of current, that is towards a region of decreasing potential, then the value of the potential drop can be taken as negative. So what you need to remember is that while traveling around the loop, when you come across a battery or a resistor, if you are traveling towards a region of high potential, then it is always positive. At the same time, when you are traveling to a region of low potential, then the assigned values for EMFs as well as potential drop across the resistors would be negative. So with these concepts in your mind, let's try to solve a problem. So this is a circuit diagram given and you're asked to find the current in each branch of the circuit. Now when you get such a question, first of all, look at the circuit diagram closely to find any series or parallel combination so that you can simplify the circuit by drawing its equivalent circuit diagram. So here you can find a parallel combination, is it not? Now the 3 ohm resistor and the 6 ohm resistor, the endpoints are connected together, so it's a parallel combination. So you can find the equivalent resistance for this parallel combination. Let's do that first. 1 by R prime, I'm calling it as R prime, is equal to 1 by 3 plus 1 by 6. On solving, you would get the equivalent resistance R prime as 2 ohms. Right. So now let's redraw this circuit diagram to find the equivalent circuit diagram. All right. So here we go. This is the 12 ohm resistor and you have a 6 ohm resistor here. Here there is a 3 ohm resistor come across a 21 volt battery, and at this point you can very well replace the parallel combination with the 2 ohm resistor. Here it is 6 ohm, this is 3 ohm, this is 12 ohm, 18 volt and 21 volt. All right, so we have obtained the equivalent circuit diagram. Now we can use the Kirchoff's laws to solve the circuit. All right, so first thing that you need to do is apply the, first thing you need to assume the current direction. So what I basically do is begin with the positive terminal of a battery. Okay, so from this 18 volt positive terminal, a current I is flowing in this direction. This is the assumed direction for current and it is moving across a 12 ohm resistor. And at this point here you can see a junction. Okay, so the current I would split up into 2. It is I1 flowing across 6 ohm and I2 is flowing in this direction across 3 ohm. Okay, so I2 will be flowing like this and I2 will flow across 2 ohm in this direction. And again, here you have a junction. So at this point, I1 and I2 would meet and the current that is coming out would be the sum of 2, I1 plus I2. That is equal to I. So current I would reach the negative terminal of 18 volt. So we have distributed the currents and also we have assumed a direction for these currents. And the next step, what you need to do is apply the junction rule, right? So we would apply the Kirchoff's current law in order to solve the circuit, that is I equals I1 plus I2. So this will be our first equation. Now you need 2 more equations because we have 3 unknowns here, I1, I2. So in total, we need 3 equations to solve for the unknowns. So as the next step, we would apply the Kirchoff's voltage law for any chosen loop. So let me mark these points in order to identify the loops. All right, A, B, C, D, E, F. Now choosing this loop, A, B, E, F, A. So this is my preferred direction. I prefer going clockwise in this loop. Not necessarily. According to your convenience, you can choose clockwise or anti-clockwise, but because most of the currents are moving in this direction, I prefer clockwise direction. That's all. So let's begin applying the loop rule. So while moving across the 12 ohm resistor, I am moving from a positive terminal to a negative terminal. That means a region from positive potential to a region of negative potential to a region of decreasing potential. So that means I can very well assign a negative sign for the potential drop, that is minus 12I. All right. And now across the 6 ohm, I am moving along the direction of the current. So again, moving in the direction of decreasing potential. So again, it is minus 6I1. Then here there is no circuit element, so there is no potential drop. Then coming across this battery, clockwise means I am moving from negative terminal to positive terminal in the region of, towards a region of increasing potential. So let me give it a positive sign. Plus 18 equals 0. So this would be my equation 2. Now let me choose another loop to find the third equation. Say this is the loop, and again I am moving in the clockwise direction. So that is in the loop B, C, D, E, B. Now moving across this resistor 3 ohm, I am moving along the direction of I2. So along the direction of decreasing potential. So it would be minus 3I2. Coming across the battery 21 volt, moving from negative terminal to positive terminal, moving towards a higher potential region. So let me give it a positive value, plus 21. Then coming across a 2 ohm resistor, I am moving along the direction of I2. So that is towards a region of decreasing potential. So again, minus 2I2. And how about the 6 ohm? I am traveling in a direction opposite to the current. So I can give it a positive sign, plus 6I1 equals 0. So on solving, what would I get? Minus 5I2 plus 6I1 plus 21 equals 0. All right. So we have obtained the 3 equations. Now what you need to do is simple mathematics to solve these 3 in order to find I, I1 and I2. So now this term, you see the unknowns are I and I1, and for this equation it is I2 and I1. So what I can do is I can replace this I in terms of I1 and I2 so that I get 2 equations in terms of I1 and I2 for solving. All right, so substituting for I in equation 2, minus 12 into I1 plus I2 minus 6I1 plus 18 equals 0. So what would be the equation? Minus 18I1 minus 12I2 plus 18 equals 0. So this would be our 4th equation. Now we can very well solve equation 3 and 4 in order to get the values of I1 and I2. All right. So what I can do is, for simplifying, I can multiply equation 3 by 3. Okay. And then the equation would be 18I1 minus 15I2 plus 63 equals 0. Now simply add these 2 equations. Then what would you get? Minus 27I2 plus 81 equals 0. Therefore, I2 is equal to 81 by 27, which is equal to 3 amperes. So we have obtained the value for I2. So substituting I2 in any of these equations, I can find the value of I1. So substituting for I2 in, say, equation 3, what would I get? Minus 15, okay, minus 5 into I2, minus 5 into 3, plus 6 I1. I1 plus 21 equals 0. On solving, what would you get? I1 is equal to minus 1 ampere. This would be the result. So you have obtained a negative value in the answer. Just means that the direction of I1 is opposite to the direction that we have assumed. That's all. That's the meaning of this negative sign. Okay. So now what we have to find is, we do not know I, so we can find I from this equation 1. I is equal to I1 plus I2, that is 3 minus 1, which is equal to 2 amperes. So thus we have solved for the unknown values of currents I, I1 and I2, and we have solved the circuits.